All right, so what's the difference between AI, machine learning, and deep learning? Well, this chart shows the difference between them. So as you can see, AI is the largest circle, machine learning is a subsection of that, then deep learning is a subsection even further of that. So AI, artificial intelligence, includes machine learning. Machine learning is a type of AI, but AI is not a type of machine learning. And it's the same for deep learning and machine learning, just one layer deeper. So AI is the attempt to automate intellectual tasks that are usually performed by humans. This means that any attempt to do a human task with a machine is considered AI. Machine learning is so regular programming works by creating the rules and the data and giving them to a machine, then you get answers back. So you write a program that then takes in rules and data, or the rules are the program, and then you give it data, and then it gives you the answers back. Machine learning works sort of the opposite way. You create the data and the answers, you give that to a machine, and then you get out the rules in whatever the model is. It learns it learns the transformations by itself. So here's that example. Rules and data go into classical programming, and you get answers out. Data and answers go into machine learning, and you get rules out. Some problems become very easy to solve when the data is different. So all machine learning is actually doing is just filtering data from one state to another. So an example of a problem that is very easy to solve when data is different, if you're using HSV, hue saturation, I forgot what HSV exactly stands for. Hue saturation value to represent colors, which is basically representing it like this. Then controlling the red pixels of a picture is very hard because you basically have to then determine what's a red pixel. It's just really hard to find. But if we're using RGB, for example, the format's easy. We just select all the red pixels because they're part of that format. And in this format, it's easier to change the hue and it's easier to see the hue. Same thing, same exact image, different representation and different problems that are easier or harder. Machine learning can be seen as creating these transformations. For example, say we have this sample data right here. We have a bunch of points on a grid system, and we have white points and we have black points. If we want to categorize the black and white points, it's kind of hard. Like you can write a program to say like, oh, well, you sort of want to draw it this far away from white points, this far away from black. It's just hard to find that diagonal. However, if we apply a coordinate change, it becomes very simple and a possible problem. So if instead of like this, we apply a coordinate change and then all the white dots are on the left side, the black ones are on the right side, it simply to categorize this just becomes, is it less than 0 or is it greater than 0? So that's what machine learning does. It learns these representations and these transformations automatically. So you get data that's put in like this, and then it comes out like this, and then it just basically says, is it a 0 or a 1? Is it below 0 or is it above 0? So deep learning is machine learning, but there's just more layers. That's why it's called deep. It's not more understanding. It's not more philosophical. I wish it was, but it's not. It just has more layers. Machine learning might have one or two layers of these transformations, but deep learning will continue to stack them continuously. So here's an example of a deep learning model. You have an input of like a number here. Then you go through layer 1, layer 2, layer 3, and layer 4. And then your final output is something like this, where then it's 0, 0, 0, 0, 1, 0, 0, 1, etc., or something, where then it categorizes it as a 4. And here's what that looks like, except for with some of the representations the model might learn. So it takes in this image, and then it applies these transformations it learns over hundreds of thousands of iterations. And in this case, gets out like, it converts it from here to here, here to here, here to here, then here to here with this final value, which we ascribe a representation to of the number 4. So here's how deep learning works roughly. Step 1, give an input x to a model with layers. These layers have weights that store its knowledge and get back predictions. So input goes in here to these layers that have weights. These weights represent its knowledge, and they also are what are updated for automatic learning. So then from there you get predictions just right away. Then step 2 is to take those predictions and compare them with what the answer should have been. So that's what this looks like. You take in those predictions, you compare them with what they should have actually been, and then you do that with a loss function, and that gives you a score. Basically, how correct, how right was the model. So then for step 3, you use that loss function with an optimizer to update the weights, which is the knowledge, so that the machine can learn. So you pass that in with an optimizer, and then you update weights so that you can say, don't apply these transformations this way, apply them so it gets closer to this value that it should have been. And that's it. That is how these models learn. If you can understand this, you understand the high level of how deep learning works. Yeah, there's a few actions down here. Thank you guys for watching. If you're not watching this on school, all of this is in my community, Python developers, school.com/coder. It'll be the top link. And in there, I'm working on a full deep learning course. So if you want to continue with this knowledge and gain more insights, you should join the community. It's completely free.